So the question we are looking at over here is combination sum 2. We have already done combination sum 1. Now the biggest difference in this is that over here it says each number in candidates may only be used once in the combination. The solution set must not contain duplicate combinations. So, which means that when backtracking, we are going to use I plus 1 and we are going to use backtracking. So if you have not watched the combination sum video, I do suggest watching that because I'm basically just building on top of that. So this is the code. Over here, we will do the same thing, but we are sorting the candidates A. And the reason why we are sorting it is that so we can compare it. I'll further explain, for example, this loop where we are comparing the current candidate with the previous one. So that's why we are going to sort our candidates. And then we are going to skip the duplicates which are on the same tree level. And then since it's sorted, once we exceed remaining, we can stop entirely, so we can break out of the loop. And then we do the same thing, which is we are appending. Over here, as I said, we are going to do I plus 1 because each element is used at most once, and then we do the pop. So we do the choose, the explore stage, and then the unchoose stage in the classic backtracking. Now, this candidate sort, what it does is that it will group all equal numbers together, and this will let us prune early. So inside backtrack over here, what we are doing is we are saying if I is greater than start and the candidates of I is equal to candidates of I minus 1, which is the previous one. So this is checking a very crucial part for uniqueness, that at any given recursion level, we only allow the first occurrence of a repeated value to start a branch, and then later duplicates at that same level are skipped because any combination that they would produce was already produced by the first one. So duplicates are still allowed across levels, and that's why we are comparing it to start over here and not 0. I'm going to explain it further in this. So over here, when you look at this tree, if you look at this red and green box at the bottom, so the tree branches on I equals to 0 and then I equals to 1 at this top level. Now both are value 1, and then at each of those branches independently it goes on to pick the 2, producing 1 equals to 1 comma 2. Now the array has 2 ones, so from the algorithm's point of view, it picks the first one and then it picks the 2. And then it thinks that they are different paths, but they basically yield the identical combination. And that's what we are trying to kill. That's what we don't need. We don't need this duplicate. So in result, when the code that we had written, where we are comparing I to I minus 1, candidates of I to candidates of I minus 1. So if you look over here, this whole middle branch is gone, because when the loop in this root frame, in this I equals to 0, when it reaches I equals to 1, it will fire that is I greater than start, which is 1 is greater than 0, which is true. And then candidates of 1 is equal to candidates of 0, which means 1 is equal to 1. So we continue, which means in the code it says continue, which means we skip before any recursion happens. So the branch that would be reproduced 1 comma 2, it never gets built, and that's how we get to leave it early. And then over here, as I said, we are checking I if I is greater than start, because it basically means that if this is not the first element my loop is considering. So we only skip a repeated value when we have already tried that same value earlier in our current loop. So the first pick of any loop, which is I equals to start, it is always safe because nothing came before it to duplicate. And that's why we have this That's why we have this guard over here. And that's why we compare anything that appears after. So if I is greater than start. And yes, that's the solution.